Good day, my dear viewers. Today we are going into another statistics, which is a measure of association. It is a specialized approach to establish relationship when the data you are considering is at the interval level or they have been categorized, especially when both are categorized or one of them, which is the dependent variable that you are interested in, are categorized. So we have what we call chi-square. So chi-square is known as a measure of association, usually suitable for data that are measured at the interval level. In this example that we have here, you are seeing socioeconomic status of respondents and their academic performance. Socioeconomic status is in three levels: low, medium, and high. While academic performance is also in three levels: excellent, good, and fail. By implication, this table is known as the summary table, chi-square summary table, telling us that for those that are low, 15 of them are excellent, 32 are good, while 30 are failed. While for high, 30 are excellent, 45 are good, and 11 are failed. But because this is descriptive in nature, and that is one thing that you have to also take note. For your information, some people will say chi-square is like a descriptive statistics. In fact, I have seen somebody argue with me, but I was able to tell that person that if you are only stopping at this summary table, it is not chi-square, it is just cross tabulation. And when you say cross tabulation, you are cross tabbing this variable with this variable. That is not chi-square, that is still descriptive level. But once it is chi-square, it's an hypothetical approach to solving it. So you don't describe, you are either confirm or otherwise. So it is not a descriptive statistics, it's what? An inferential statistics. Except otherwise, if you stop here, you are only describing, and this is not chi-square, this is just summary table telling us cross tabulation. So take note of that. However, for chi-square, there are many things that you have to put in your mind. All these variables that we have said are what we call observed variable, what you can see. So you can see that 15 is low and they are excellent. That's observed. We also have another thing we call expected variable or outcome. So these are the observed variables. So we need expected figure, and that's what you are going to compute. For computing expected, you are going to do some computation which will tell you the row and column. How many rows do we have here? Most times, this is a 3 by 3 matrix, telling us that we have how many rows? 3 rows and 3 columns. So sometimes it can be 3 by 2, it can be 4 by, it depends. But this is a 3 by 3, 3 rows and 3 columns. So you will need row total, you need column total. That's first impression for you to be able to compute your expected value. And more importantly, when you are able to get your chi-square value, there is another thing that we will compute after this example. We call it coefficient of contingency. That one is trying to tell us how contingent is your data. It's a further test for statistics. It's a further statistical test rather that will help us tell us how contingent is your data. That will also take care of your chi-square value and your n. Your n is the total number of samples, which we will also know as time goes on. So for us, we have row and we have column. So we ab initio have to compute row and column total descriptively. So let us do that. So we have total and we have total. We have total here too. So we create another column for total so that we can compute our row and column total respectively. Without much ado, for this is a particular row, this is a particular column. We have 15 plus this, 45 plus 22 will give me 67. So we have 32 plus 42, and that will be 74. 74 plus 45 will give you 119. we have 55 plus 11, and that will give you 66. So these are the total for this. So this is row total 1, row total 2, row total 3. Take note. Column total now. 15 plus 32 is what? This 62 plus 15. 77. 22 plus 42 is 64. 64 plus 25 will be 89. We have 75. 30 plus 45 is 75. 75 plus 11 will give you 86. Now this is, I will say this is row 1, row 2, row 3. This is column 1, column 2, column 3 total. But there's a grand total too. I want to say there's a grand total, meaning when you sum this and sum this, it's going to be the same thing. That is another check to know whether you are right or you are wrong at this first step. When you add 67 plus 119 plus 66, it must give you the same thing. Let us do that. 67 plus 119 plus 66, it will give you what? 67 plus 119 plus 66, it will give you 5252. So when you add 77 plus 89 plus 86, it will also give you 252. That's initial check to confirm whether you are right when you are doing the row total and the column total. Once we are able to compute row and column total, just like we have computed, the total for this is 67, this is 119, this is 66, column total. You will verify that you are right when the grand total is equal. The sum of all these and the sum of all these must be 252. Meaning, if they are not 252, one of them is wrong. But by the time they are the same, then at the initial stage, you are right. So you now need to compute the expected. Like I have said, these are observed values. You now need to compute what? The expected. Take note, this is row 1, column 1. It implies that you will do what we call row 1, column 1 divided by grand total. Meaning, row 1 total, column 1 total divided by grand total. That will give you the expected value for this. So it implies you have row 1, column 1. That will be 77, 67 times 77 divided by 252. That will give you the expected. This one is row 1, column 2. And that will be row 1, column 2. Row 1, column 2 is 67 times 89 divided by 252. This is row 1, column 3. Row 1, column 3. I am doing this so that you will be explicit enough. And that will be 67 times 86 divided by 252. You also do it for the other ones. So that will be row what? Row 2, column 1. Row 2, column 1 will be 119 times what? 77 divided by 252. Row 2, column 2 will be 119 times 89 divided by 252. Row 3, column 3 will be 119 times 86 divided by 252. Then the other one, which is the third row, we have row 3, column 1. Row 3, column 1 is 66 times 77 divided by 252. Row 3, column 2 will be 66 times 89 divided by 252. Row 3, column 3 is 66 times 86 divided by 252. All the values that you are going to get now will be your expected value. Let us now do that. this 67 times 77 divided by 252. Let us do this simultaneously. 67 times 77 divided by 252. That will give us 67 times 77 divided by 252. 20.47. So I am putting it in brackets. 20.47. This is your observed, this is your expected. Let's continue. 67 times 89 divided by 252. 23.66. 23.66. 67 times 86 divided by 252. 22.86. 22.86. Observe, expected. Observe, expected. So let's go to the second one. 119 times 77 divided by 252. 36.36. 36.36. 119 times 89 divided by 252. 42.02. 42.02. 119 times 86 divided by 252. 119 times 86 divided. So once you are able to get the expected value, then you go to the next one, which is row 3 column 3, and that will be 119 times 86 divided by 252. You have to take it one by one, because if you are not careful, you go and do the row and the column, and that will be a mixed up. So that will give us what?
40.61.
40.61. And you can see I'm writing it immediately so that it will not be mixed up. 66 times 77 divided by this. That will be for the third row 3.
20.16.
20.16. 66 times 89 divided by 252. 23.3. 23.31. Then the last one, 66 times 86 divided by 252. 22.52. 22.52. Now, having done this, you have been able to tell us the observed. The observed is given. You have been able to compute the expected. And the formula says, the chi-square formula says, summation of. Now, if you look at this, it is summation. That summation is taking care of everything. So that means both the numerator and the denominator. But before you can sum all the everything, you have to do one thing. Observe minus expected square divided by expected. So that's where you have to be careful. Now we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have to compute observe minus expected square divided by expected in 9 places. So let's do that. Our chi-square will now be, what's our observed? 15 minus what our expected? 20.47 square. What our expected? 20.47. That's, I said in 9 places, you have done one successfully. Plus, you know, it says summation of, so that means you are summing all of them. You will take the second one, I'm taking it one by one, so I will not mix it up. This one will now be 22 minus 23.68 square divided by 23.68. We are done with the second one. We are still going to 9. The third one, 30 minus 22.86 square over 22.86. The fourth one, 32 minus 36.36 square, 36.36. The fifth one, 42 minus 42.02 square over 42.02. The sixth one, 45 minus 40.61. Then you square it, divided by 40.61. The seventh one, 30 minus 20.16 square, 20.16. The what? The eighth one, 25 minus 23.31, then you square, divided by 23.31. Then the last one, 11 minus 22.52, then you square, divided by 22.52. Just like you are reading it out, you also use your computation one by one. You are going to be getting 9 values that you will sum together. So you have 15 minus 20.47. The value you will square it. Please do that. 15 minus 20.47. What do you get?
29.9.
The value squared. Square it. How have you squared it? Divided by 20.47.
1.46.
That's 1.46. So you are done with 1. You are still going to 9 places. 22 minus 23.68. Then you square it. Divided by 23.68. 0.12. The third one now. 30 minus 22.86. 30 minus 22.86. Then you square it. Divided by 22.86. 2.23. The fourth one, 32 minus 36.36. 32 minus 36.36. You square it, then you divide it by 36.36. 0.52. The fifth one, 42 minus 42.02. 42 minus 42.02 square divided by 42.02. 9. Please check. 42 minus 42.02. Square divided by 42.02. 9. Because what I'm seeing here is 42 minus 42. 42 minus 42 should give you what? 0.02. That will give you what?
That's 0.02.
Then square.
That's 4.04.
Then you are dividing by 42.02. 9.5.
5 to approximate
9.52. 45 minus 40.61. 45 minus 40.61.
0.47.
Have you squared it?
Yes.
Have you then divide by 40.61?
That's 4.39.
4.3.
No square.
Okay, divide by 40.61.
0.47.
0.47. That's the argument I have for this. Because I am thinking this one should be 0 point something, not 9 point. Because when you say 42 minus 42, that's 0 point something squared. 0.02
0 minus 0.02.
squared.
Square.
That would
That's
be
4.04.
divided by 42.02.
By
0.02. Okay, so the net minus 0 point what? Because it is important we check this value. It's an outlier. I want to say something is an outlier. It's telling us that something is wrong.
42.02. Square.
The answer, you square it, divided by 42.02.
Divided by
42.02.
that's it. 0.9.
How many zeros?
6.
6 zeros.
Yes.
So that means here we have 0.47. So this is 6 zeros, I mean.
Yes.
0.1, 2, 3, 4, 5.
9.
Then 9 what?
9.5.
9.5.
60.
So plus 0.47. So the next one, without wasting much time, 30 minus 20.16. 30 minus 0. Is it minus? So if it is minus,
No,
then
it's not minus.
okay.
As in it will give us that 0, 0, 0. So it has approximated.
Alright. So here now you have the next one, which is 30 minus 20.16. 0.16. Then you square it. Divided by 20.16. 4.8. 0 what? 02. Then the next one, 25 minus 20.31. Then you square it. Then you divide by 23.31. That will give you 0.122. Good. The last one that we have here, 11 minus 22.52. 11 minus 22.52, observe and expected. Then you square it, divided by 22.52. 5.89. So after taking our time meticulously, we can then add 1.46. Please do 1.46 plus 0.12 plus 2.23 plus 0.52 plus 0.0000095
6 0.
0.0000095 plus 0.47 plus 4.802 plus 0.122 plus 5.89. So it will give us what value? 15.61. Our chi-square value is 15.61. Obviously, if this is our chi-square value, we call this chi-square calculated. Just like I have said, if this is chi-square calculated and we want to confirm in the table values our chi-square calculated, degree of freedom says R minus 1, C minus 1. How many rows do you have?
3.
So that means that you have 3 minus 1, 3 minus 1, 3 rows, 3 columns. So 3 minus 1 is 2. 3 minus 1 is 2. 2 times 2 will give you what? 4. That means your degree of freedom is 4. If this is your chi-square calculated and your degree of freedom is 4, so your chi-square tabulated will be that you will go and check in chi-square table, contingency table, under degree of 4 with level of significance 0.05 in social sciences. And from there, you will then compare your calculated value with your tabulated value so that you can either accept or reject your hypothesis that there is a significant relationship. When I say relationship, between socioeconomic status and academic performance. More importantly, when you say coefficient of contingency, now that you have the chi-square value of 15.61, 15.61 is your chi-square value. By implication, if you say you want to compute your coefficient of contingency and you have your chi-square value to be 15.61, the value is 15.61. No, chi-square. It's not raised to power 2 because of the square. So 15.61 divided by 15.61 plus n. What's our n? This is where you have to take notes. Our n is what?
252.
Is our n 252? This is grand total. Our n should be what? You will now know how many students are here? 15. So our n is 252. That means you are looking at 252 students. Out of 252 students, 77 of them are from low, whatever. 89 are from medium. 86 are from high. Out of 252 students, 67 of them have excellent score. 119 have good score. 66 are failed. So your n is what? 252 total sample that you are working with. So you have to take note of that. So 252. By that, you will then have square root of 15.61. 15.61 plus 252 will give you what? 47.61. Is that right? 15.61 plus 252 should give you 267.61. So you divide 15.61 divided by 267.61, and that will give you what? 267.61.
Zero point 0.058.
0.058. Square root of 0.058.
3.4.
0.
Okay, square root.
Square root of
0.24.
0 point what?
24.
No, it's not square, it's square root. Square root of 0.058.
Yes.
It will give you 0 point what?
24.
0.24. This is your coefficient of contingency. So if the person is concerned about compute coefficient of contingency, it implies that you have to first of all get the chi-square value first before you compute coefficient of contingency. And if the question now says, let me shock you. If the question now says the coefficient of contingency is 0.24, what is the chi-square value? Do you know that you don't have to go through all this? The only thing you only need to do is to find the grand total, and you will do substitution effect. When I say you do substitution effect, it implies that you will denote chi-square to be a value. Let's say x. You will now say square root of x divided by s plus and you will do some. That shows that all those things that you are teaching you does not waste. But before you can do substitution effect, you must understand substitution, you must understand factorization, you must understand all those things. Well, that is a reverse case. So thank you for watching. Remember to subscribe.